Okay, so this is linear inequalities. And first we have to know what inequalities are. So we have these symbols. These are inequality symbols. And this one is greater than. This one is less than. We also have greater than or equal to, and less than or equal to. Okay? And whenever we graph them, we're usually graphing them on a number line. So whenever we use greater than or we use less than, we always use a open circle. Okay? So on the number line, you're going to do an open circle. And whenever you see this sign or this sign, the greater than or equal to or less than or equal to, you're going to use a dot or a closed circle. Okay? So just real quick, some examples. It says graph the inequality. Well, there's nothing for me to solve. All I have to do is graph it. So I look at my symbol. I know that it's greater than or equal to, so I'm going to use a dot, and I'm just going to find that number, and I'm going to make a dot there. And I usually put them above the number. And then I'm going to go ahead and draw my line because x is greater than -2. That means everything that's greater than it as well as equal to it is a solution. So B, same thing here, except I have a compound inequality here. So a compound inequality means that we have two inequalities going on at the same time. And this one is actually a conjunction. This is a and statement. Okay? And whenever you have and, that means that we have two things going on, and they have to be going on at the same time. So my answer should be something that goes towards each other. So because both of them have to be true in order for it to be true. If one's going this way and one's going this way, the only place that's the answer is where the two meet. So if I look here, -1, I know I need a closed circle there, and my arrow should be going this way. I also have x is less than 2, so here I have an open circle. But if we notice, if we drew lines, this one would be going this way, and this one would be going this way. So again, they cross each other, and because it's an and statement, it means both of them have to be true. Well, the only place where both of them is true is where the two connect. So I'm actually going to just connect these two. And that is our answer. Okay? So conjunction always goes together. The two meet in the middle. C, we have what we call a disjunction, and this is a or statement. So x is greater than 5. Well, that means that I have an open circle here, and since it's greater than 5, my arrow is going to be going in that direction. Okay? For this one, I have x is less than or equal to -1. Well, less than or equal to means I shade it in. X is less than that number, which means it's going this way. And yes, my graph does do what it should do. If it's a disjunction, one should be going towards negative infinity, and one should be going towards positive infinity. We have to remember two things. One, first is all rules of solving equations apply. So just like with regular algebra, when you have an equal sign, what is done to one side must be done to the other. Okay, so all the same rules of manipulating equations work for inequalities. But we have these two new rules. The first one is if you multiply by or divide by a negative number, your inequality symbol is going to flip. So if it's facing one way, now it will be facing the other way if you multiply or divide by a negative number. The second one is if you flip the equation, then the inequality also flips. Okay, so if we take a look at this example here, I'm going to do both of what I just said here. I'm going to do rule number 2 first because I don't like my x over here. I want to move it over here. And if I do that, then that means I have to take my 10 and move it over here. So -5x and 10. Usually it would be an equal sign. I would just write equals, and that would be fine because I moved everything on this side over to this one, everything on this side over to this one. But now I have an inequality symbol. I have to change, or I have to flip that inequality. Okay? That's the only way these two statements are the same. Okay, now I want to solve for x, and if I do that, that means I need to divide by -5. Well, now I just did rule number 1, which says that if I multiply or divide by a negative number, I have to flip my sign. So again, my sign's going to flip, and I'll get my answer. Okay, so these rules are very, very important. You have to watch out for them. I know negatives are kind of hard to remember, but we need to try and keep those in our mind when we're doing these problems. Okay, so example number 2. Oops, my board's fallen. Solve and graph the inequality. So example number 2 says 3 minus x is greater than x minus 9. So I'm going to solve this, and I want to graph it when I'm done. Let's go ahead and solve it first. First, I want to move the 3 over here, and I'm going to subtract x at the same time. Okay, so we have to remember negative x, that's negative 2x. My symbol is going to stay exactly the same because all I did was add or subtract. I didn't multiply or divide by a negative number. Negative 9 and negative 3, well, that's negative 12. Divide by negative 2. And that's very important. I just divided by a negative number. My sign flips. Okay? X is less than 6. Okay? And I'm going to graph that in just a minute. So let's take a look at this one. We have, looks like I lost my signs. This is supposed to be here and there. So 2 is less than 3x minus 1, which is less than or equal to 6. So if I'm going to solve this, there's 2 ways I can do it. I can separate them. I can make them 2 inequalities, but what I like to do is I like to kind of draw a line down like this, and then I think, okay, usually in algebra, if I do something to one, I have to do it to the other. Well, here, this kind of equation, I have 3 pieces. So what I do to this one, I'm going to have to do to the other 2. So I want to have x stay in the middle. So I'm going to try and get x by itself. So to begin, I'm going to add 1 to all sides. And in the middle, I'm left with 3x. I didn't multiply or divide by a negative, so my signs stay the same. Now I need to divide by 3. And again, since I did it to one, I have to do it to the others. I get 1 is less than x, which is less than or equal to 7/3. Okay, so let's take a look at C. So C, we have a disjunction. We have or, okay? And that means that I need to look at each of these by themselves. And this is missing a sign, but it is 3x plus 7 is greater than or equal to 37. So this is the one I'm going to deal with first. So if I do this, I get subtract 7 from both sides, and I get 3x is greater than or equal to 30. Divide by 3, I get x is greater than or equal to 10. Okay, but I still have to worry about this piece, so I'm going to rewrite this one. And in this one, all I have to do is divide by negative 2. And again, I divided by a negative number, so I have to flip my sign. Okay, so I found my 2 answers. I have x is greater than or equal to 10, and x is less than or equal to negative 5. Now I'm going to graph, and on this graph, I'll start on this one and work my way back. Again, whenever I'm doing this on my own, all I care about is that my number line makes sense. In this case, negative 5 is less than 10, so it's on this side on the number line. X is less than, which means it's an open circle, and it is a disjunction, which means my lines should be going away from each other. Okay, so one line going that way, one line going this way. This one I have 1 and 7/3. So you want to make sure that you know that 7/3 is larger than 1. And 1 is less than x, which means I have a circle, and my line's going this way. And x is less than or equal to, which means I have a dot, and my line is going this way. So again, this is a conjunction, which means the 2 should connect. And my final number is right here. Whenever you just have a simple one, all I care about is having that one number there. It's going to be an open circle, and x is less than that number. So my arrow or my line is going to be going that way. Okay? That's it.